Hello. In the last video we have seen basic types of signals and then we have discussed continuous and discrete time signals. So now it is time to define operations on those continuous and discrete time signals. We have discussed for continuous and then discrete time signals, we have seen some of the parameters, that is if you have to calculate, let it is for continuous time signal x of t, it is continuous time signal, and if it is discrete time signal x of n. Then we have seen that if we have to find out the area of these two signals, then area of x of t you have mentioned just as integration from minus infinity to infinity signal x of t dt. Similarly, in the case of discrete time signal you have written area of x of n, it is equals to summation from n is equals to minus infinity to plus infinity signal x of n. So it is by the definition you can find out the area. Similarly, you have defined one more thing, that is if you have to check absolute integrability, then you have written that if integration from minus infinity to plus infinity magnitude of x of t dt, if it is less than infinity, then the signal x of t is said to be absolutely integrable. Similarly, if you have written that any signal, for any signal x of n, summation from n is equals to minus infinity to plus infinity magnitude of x of n, if this value is less than infinity, then you told that this signal x of n is absolutely summable. So now absolutely summable. So now we have to define some operations that you are going to perform on any continuous or discrete time signal, and you will be taking the effects of that operation on various parameters that are going to be area, that will be absolute integrability or absolute summability, that will be the existent duration of any signal, that will be the time width. So all of these parameters are we are going to discuss for every operation that we will be performing. So to understand the operations, there will be 5 operations that we will be discussing in this lecture, and the first 2 operations are independent of time, that is that are not related to time. Therefore, it is possible to perform those first two operations on a real time signals also. But after that 2 operations, we will be discussing 3 more operations that are closely related to time, and therefore it is not possible to perform those 3 operations on any real time signals, but it is possible only to perform those operations on a recorded signal. So to start with, if we want to see the effects of operation on various parameters, so we can just take a easy signal to understand all the operations. So if you see, let it is a signal x of t. Let this signal x of t is existing for 0 to 10 seconds with the value, let it is having the value 5. It is the general representation of x of t with respect to t. How you mathematically define this signal? Either you can write x of t is equals to 5 for t in between 0 and 10, and it is equals to 0 otherwise. X of t is equals to 0 otherwise. Either you can write like this, the signal x of t is having a value 5, but only in the duration when the value of t is in between, this is your origin, that is the point of t equals to 0. Therefore, this signal is present only in the duration from t equals to 0 to 10 seconds, and it is having a constant value 5. So you can represent this signal x of t as 5 for 0 to 10 seconds and 0 otherwise. This point that we have written 0 otherwise, it can be written as also as 0 for either t less than 0 and t greater than 10. Sometimes you can have the representation written like this also, that this signal is 5 for 0 to 10 seconds, and this signal x of t is 0 if we take t less than 0, or we take that value of t to be greater than 10. As we can see here, after 10 signal is 0, before 0 signal is 0. So there can be different type of representation also for continuous time signals. So now if you see here, if you want to have the value of areas or area of the signal, then what is the area of the signal? If you want, then you can use this integration, or otherwise you see here, if it is a rectangle, then its area is just going to be its width multiplied by height. So the width is 10 seconds and the height is 5 units. Therefore the area, if you define the area of the signal, then area of the signal is going to be 5 into 10, that is equals to 50 square units. Now as you can see, the signal is having positive values only. Therefore the result of these 2 integrals, that is integration from minus infinity to infinity, either x of t dt or either you take magnitude of x of t dt. These two integrals are going to be same in this problem especially. So if you see here, it is a real signal having positive values only, therefore these two integrals will be the same for this signal. Therefore this signal you can say that absolute integrability is satisfied, because integration from minus infinity to infinity magnitude of x of t dt will again going to be 50. Therefore you can say that it is a continuous time signal which is limited in time. You can also say that this signal is existing only for a finite duration, therefore it is a finite duration signal or a limited in time signal, and for this signal the area is 50 and this signal is absolutely integrable also. So now if we are going to discuss the properties, the operations, so we are going to take the first operation, that is amplitude scaling. The first operation we are taking is amplitude scaling, and to perform this amplitude scaling we have to find out for the given signal x of t, we are first taking the continuous time signal case, then we will be discussing the discrete time signal also for the same operation. So the first operation, amplitude scaling, we have to find for given signal x of t, we have to find k times x of t for given signal x of t, for given x of t. Now if you see here, if you these two operations, the first two operations that we have discussed earlier, that we are going to see here, amplitude scaling and amplitude reversal, in these two operations you can understand that you are just multiplying the signal by a scalar, that is by a constant. So this k is a constant, and if it is amplitude scaling case, then this k can be, this k for amplitude scaling only, this k would be greater than or equals to 0. This k will not be negative, because for negative values of k we will separately define another operation, that is amplitude reversal. So if k is greater than or equals to 0 and if this k is a constant, then what you are going to do is you are just going to multiply the values of the signal x of t with this constant value k. You have to find out, for the given signal x of t, if we have to find with respect to t, we have to find 10 into x of t. What we have to obtain now? 10 into x of t, where we have taken k to be this constant k, we are taking 10. So if it is x of t and you will have to plot 10 into x of t, then you just have to multiply the amplitudes of x of t, which was earlier 5, with this constant value k. So now this amplitude, the existence duration will not get changed due to this operation, that is amplitude scaling. We have already mentioned that first two operation will not have any effect on the values of time. Therefore this signal is again going to be from 0 to t is equals to 0 to 10 seconds only. It is going to exist only in the same duration, that is 0 to 10 seconds, but now the values of this signal will be, earlier it was 5, now it will get multiplied by 10. So the value will be what? 50. Now if you see here, if the value is 50, then what is now the area of this signal? It is our signal k times x of t, k times x of t. So if you see the area of this rectangle now, it is again a rectangle, therefore the area will be width multiplied by height. Width is again maintained at 10 seconds, but now the height is what? 50. So the area will be 50 into 10, that is 500. Area is now, let it is a dash, then a dash is equals to 500. Earlier what was the area? Earlier the area was 50 and now the area became 500. So if you have amplitude scaled this signal by 10 unit, then the area get multiplied by this scaling factor, that is 10. So now if you have to see the effects of this operation, if you want to see, then if you see the area, time width, absolute integrability. So now we are taking the effects of this operation, that is amplitude scaling. So before amplitude scaling the area was 50, and after amplitude scaling by a factor of 10, the area get multiplied by the same factor, that is 10. Therefore you can say that if the area of x of t was a, then the area of signal we are saying for x1 of t, that is k times x of t. We are discussing all these values for a signal x1t, that is amplitude scaled version of xt by a scaling factor of k. So the new area will be A dash is equals to k times the earlier area, that is k into A. Time width, if you see here, the signal was earlier existing for 10 seconds, again it is existing for 10 seconds only. Therefore, you can say that time width is maintained. Maintained, that is not changed. Not changed. Similarly, if you see here, we have discussed that this signal was real and having positive values only. Therefore, we have discussed that for this signal x of t, these two integrals will be identical. These two integrals will give us the same value. The similar case is here also. This signal is again real, having positive values. Therefore, for this signal also, the integration of x of t and integration of magnitude of x of t will again have same value. And therefore, if you are going to find the value of magnitude of x of t for this signal, then you are again going to have the same value as its area, and it will be 500. So, you can see here, this signal was absolutely integrable because the value of integration minus infinity to infinity, magnitude of x of t was less than infinity. Similar case is existing here also. This signal is also absolutely integrable. Therefore, you can say that if the signal x of t was absolutely integrable, then by performing amplitude scaling, that absolute integrability property will be maintained. That is, earlier if it was absolutely integrable, then after amplitude scaling again it will be absolute integrable only. Therefore, again you can see right here, it will also be maintained. If the signal was earlier absolutely integrable, then after amplitude scaling again the signal is going to be absolutely integrable only. So now if you see the effect of same operation on a discrete time signal, we have a discrete time signal, case 2, we are taking now discrete time signal. So we are following now the sequence representation for our ease. So it is a discrete time signal which is given as x of n equals to, let it is 1, 2, 3, 4, 5. And to mention the origin, we are taking an arrow mark. If in the example, if this arrow mark is not mentioned, then you must have to take the first sample to be at origin. If the arrow is not given in the problem, then you have to take the origin at the first sample, right? Now, if you see here, let it is signal x of n. If you see here the area of x of n, then what is the value of area of x of n? Area of x of n. It is sum of all the values, that is summation from minus infinity to plus infinity. We have seen all this. So, sum of all the values will be 1 plus 2 3 plus 3 6 plus 4 10 and plus 5, that is 15. So, the area of signal x of n is 15. Again, as all of the values are positive, therefore, if you go to evaluate summation from minus infinity to plus infinity for n, magnitude of x of n, then again you are going to have the same value. That is, if you are going to write summation from n is equals to minus infinity to plus infinity magnitude of x of n, then it is again going to be 15, that is less than infinity. Therefore, you can write that this signal x of n is absolutely summable. This signal is absolutely summable. Now, if you have to see the effects of amplitude scaling, then the process will be same as in case of discrete continuous time signal, that if you have to find out, if we have to find another signal x1 of n which is related to x of n as k times x of n. If we have to find k times x of n, then what we have to do is, we just have to multiply all the sample values of x of n by this constant factor k, right. So, we have to find, let x1 of n is going to be 4 times x of n. Then what will be the values of x1 of n? x1 of n equals to, earlier the values was 1, 2, 3, 4, 5. Now, if we have to find out k times x of n, then we have to multiply that k value in all these samples values. Therefore, if the scaling factor k is 4 in this case, then 4 into 1, that is 4, next value will be 8, then 12, then 16 and then 20, and the origin will be maintained at the same place, that is at 12. Now, if you see here, if you are going to define the area of x1 of n, what is the value of area of x1 of n? For area, what you are going to do is, you are going to take summation from minus infinity to plus infinity all the samples of x of n. That is, you just have to add up all these values. Therefore, it will be 12 plus 12, that is 24 plus 16, 40 plus 20, that is equals to 60 units. Again, if you evaluate summation from n is equals to minus infinity to plus infinity, magnitude of x1 of n, it is x1 of n. So if you are going to evaluate magnitude of x1 of n, then as all of these sample values are real and positive values, therefore these two summations will have identical result and you will be having 60 only, which is less than infinity. So now what you can conclude is this signal is having this summation to be finite, therefore this signal x1 of n is again, it is again absolutely summable. It is again absolutely summable signal. So if we see here, the earlier in for x of n, the area was 15, and if you have taken a constant 4 multiplied as scaling factor, amplitude scaling factor, then now the area has become 60. Therefore, you can conclude that all of these expressions, it is valid for x1 of n, that is equals to k times x1 x of n also. If area is considered, then area dash, that is equals to area of x1 of n is equals to k into area, that is in this case earlier area was for 15 and the scaling factor was 4, therefore the area, new area was 4 into 15, that is you have get 60. Similarly, time width, if you write time width or you say number of samples in case of discrete time signals, if you are considering continuous time signals, then you take the time width, like for what value of time, how much time it is existing. But in case of discrete time signals, instead of time width, you talk about the number of samples present in that signal. So if you see here in x of n, how many samples were there? 1, 2, 3, 4, 5 samples. In x1 of n also, if you see here, 1, 2, 3, 4, 5 samples. So there is no effect on time width, that is number of samples are maintained after applying this amplitude scaling. Therefore, this value is again satisfying that x1 for x1 of n signal, time width will also be maintained, that will not be changing. And absolute integrability, or in case of discrete time signal you write integrability or summability, then it is again going to be maintained. That is, if x1 of n was absolutely summable, then definitely k times x1 of n will also be absolutely summable. So these are the effects of our first operation that we have taken, amplitude scaling. Now similar to the amplitude scaling, the next operation is operation that is, you say amplitude reversal. It is same as amplitude scaling, only the difference is you are taking the amplitude scaling factor k to be -1. If we substitute this amplitude scaling factor k to be -1, then what you will be getting, x1 of n is equals to minus of x of n. The same procedure is known to be as amplitude inversion or amplitude reversal operation. It is also known as amplitude inversion operation, right. So to find amplitude, we have to find x1 of n or x1 of t. We are taking first the continuous time case, x1 of t, that is minus of x of t. Again what we are doing is, we are multiplying x of t signal, or you can say amplitudes of x of t signal with -1, that if at the instant where the signal were earlier positive, now it will get negative and vice versa. So if you see here, we are discussing the same signal as we have taken earlier. We have taken this signal x of t, which was existing from 0 to 10 seconds. It was your signal x of t having value 5, for which you have mentioned that area is equals to 50. Now suppose you are going to take this signal x1 of t. If you have to plot with respect to t, you have to plot signal x1 of t, that is equals to minus of x of t. So you have to multiply -1 in the amplitude value of x of t. If it is 5, then what will be the value now? 5 into -1, that is -5. So value are mentioned on this y-axis. So if it was positive, then you are mentioning this to be on positive y-axis. Now it is value having -5, therefore you will be mentioning it as the time width will remain the same, that is 0 to 10 seconds only, but now the value is -1 into 5, that is equals to -5. Therefore we have plotted this signal below this x-axis in the negative y-axis only. So now if you see here, if you find out the area, what is the area? See, area, you must have read that area is never going to be negative. But if in signals and systems, if we are taking area to be positive for positive values of phi, then to mention the area is lying for the negative values of phi, you must have to take a negative sign with area. Area physically cannot be negative, but for representation purposes, we are taking the area to be negative if it is lying below this x-axis, that is below this time axis. So now the area value is equals to minus 5 into 10, that is equals to minus 50. So what you have seen here, that while performing amplitude reversal or amplitude inversion, what you have to do only, that if this is signal x of t, then just multiply this signal by minus 1, and therefore this signal is coming downside. You can also understand this process by quadrants. If you see, it is your first quadrant, second quadrant, third quadrant, and it is fourth quadrant. So whenever you will be applying your time, you will be applying amplitude reversal, then if the signal is existing in first quadrant, then after multiplying it by minus 1, it will be shifted to the fourth quadrant. First quadrant to fourth quadrant, or alternatively if you see that if the signal is represented in the fourth quadrant, that is in this section, then after you will multiply from minus 1, then minus into minus it will get positive, and therefore the values will shifted to the first quadrant. Similarly, if the function is lying in second quadrant, then by multiplying it by minus 1, the positive values will get negative, therefore it will be shifted to third, and if it is lying in third, then it will be shifted to the second quadrant. So after amplitude reversal, you just have to, as we have seen here, if it is positive, then we just have to shift the signal to be in negative side, that is plus 5 has become minus 5. It would be if, let it is having value this, let it is our signal x of t, that is having value 10 from minus 8 to plus 12. Then if you perform amplitude reversal operation, then if you have to plot x of minus of x of t, if you have to plot minus of x of t, then all these positive values will turn out to be negative. The values will be 10 into minus 1, that is minus 10, but only in between these interval, that is minus 8 to 12. So we will be having value from minus 8 to 12, and the value will be 10 into minus 1, that is equals to minus 10. So what is happening here, again this portion which was lying in second quadrant, it has came to the third quadrant, and what was lying in the first quadrant, it has come to the fourth quadrant. So simply you just have to multiply the amplitudes of signal x of t while performing either amplitude scaling or amplitude reversal or amplitude inversion. In case of amplitude inversion, you can say that it is the same process as that of amplitude scaling, but you are taking the constant amplitude scaling factor to be minus 1. The similar process will be valid for discrete time signals also. Like for discrete time signals, if you want to see, let x of n is a signal that is equals to minus 1, 3, 5, 6 and 8. Let the origin is at 6. So if it is signal x of n, then after amplitude reversal let we have to find out a signal x1 of n, then it is equals to minus of x of n. Due to amplitude reversal, we have to find minus of x of n, then we have to multiply all the samples values by this scaling factor, that is minus 1 in this case. Therefore the values would be minus into minus 1 plus 1, minus 3, minus 5, minus 6 and minus 8. So now if you see here, if you see the area of x of n, what is this? Area of x of n value 3 plus 5, 8 plus 6, 14 plus 2, 8, that is 22 and minus 1, that is 21. In this case, what is the area? It is again 3 plus 5, 8 plus 6, that is 14, 8 minus 22 and plus 1, that is area of minus of x of n. If you see, that is x1 of n, it is going to be minus 21. So now, as we have discussed in previous case, that is in case of amplitude scaling, that if area of x of t or x of n is a, then the area of k times x of t or k times x of n will be k into a. The similar process is here also. The scaling factor k is equals to minus 1. Therefore, if the area earlier was 21, then the next time when we performed amplitude reversal, then this area get multiplied by that constant, that is -1 in the case of amplitude reversal, and then therefore you are getting the value of area to be -21. So if you see here again, if the number of samples are considered 1, 2, 3, 4, 5 samples, again after performing amplitude reversal, again you are having 1, 2, 3, 4 and 5 signals only. So amplitude reversal or amplitude scaling is not going to change the time width or the absolute integrability or absolute summability, or it is just going to change the value of area of the signal as the amplitudes are going to be changed, not the time width. So these are first two operations, amplitude reversal and amplitude scaling, which can be performed on real time signals also, as you see that we can amplify using a loudspeaker the ongoing speech of any person. So these amplitude reversal and amplitude scaling can be performed on real time signals also. But now we will be confined to the operations that are related to time, and now we will be seeing the basics of function, that how we plot a function and what will be the effect if we are going to plot the same function with respect to time, and if we are going to change some of the function terms of in the function, but still if you want to plot against the time only, then what are going to be the changes, now we will be seeing. So we are discussing operations on signals, and we have seen two basic operations on signals that are related to amplitude of the signal, amplitude scaling and amplitude reversal. And you have seen that only amplitude is going to be changed, therefore only these operations have only effect on the area of the signal, but the existence duration of the signal x of t or x of n is not going to change after performing these operations. So now we have to see three more operations that are more important, you can say, as these operations are related with the time. That's why when you perform these operations, then the width of the signal, that is before applying these operations, can be changed after application of these operations. So what we have seen yet, that if we have any signal for any given signal x of t, what we have calculated till yet, we have find first signal x1 of t, that is amplitude scaled version of x of t, it is said to be k times x of t. This operation you have named it as amplitude scaling. Then you have seen another operation, that if you perform on the signal x of t, let the signal that you are going to obtain is x2 of t, then you have named it as amplitude reversal or amplitude reversal operation, that is minus of x of t. So these two operations we have discussed. Now we are going to discuss x3 of t. We have to find for this signal x of t, we have to find another signal x3 of t, which is related to this x of t, as if we are going to take x of t plus or minus t naught. Then this operation will be termed as time shifting operation. Next operation that we are going to say is x4 of t. If you plot or if you find for this signal x of t, if you have to find a signal that is x of alpha t, then you name it as time scaling operation, and this is related with x of t, x4 of t is equals to x of alpha t. We will be seeing in very easy manner that how we can perform all of these operations and how we can combine these operations on any signal. So one more operation will be there. For this x of t, we have to find x5 of t, another signal that will be related to x of t as x of minus t. So these three operations we will be discussing today. This is time shifting operation, time scaling operation and time reversal operation. But before going to discuss these operations, what you must have to keep in your mind is, if you are having any function x of t with respect to t, if you have having any function x of t, if it is any function of time x of t and you are plotting it with respect to time, so whatever will be the shape of this signal x of t is going to be maintained if you replace t on both the axes by any other function of t. Like if we have to write x of t square plus 4, and if we have written t square plus 4 only here also, then there will not be any change in the plot of plot 1 and plot 2. Let it is case 1 and let it is case 2. What we have did is, we have replaced both t's on both of the axes by any other function of t, then there will not be any change of the function. Like if you say previously, if x of t is equals to t, then you know that the graph of x of t is equals to t will be a straight line. That is, you will be having a straight line passing through the origin with the value of slope 1. That is how you plot this value x of t is equals to t. If you have to plot this graph, then you just take the values of t and x of t, that is x of t is again going to be t as defined here. Therefore, whatever value you will be taking in this t, that if you take the value of t is equals to -2, then the function value will also be -2. At t is equals to 0, you will be getting 0, t is equals to 1, you will be getting 1, t is equals to 2, you will be getting 2, and so on. So if you take all of these points, therefore, if you take all of these points, then you are going to get a straight line. It is the graph of x of t that is equals to t. Now what we have did, we have replaced both t's by t square plus 4. Therefore, if x of t is equals was t earlier, then x of t square plus 4 will be t square plus 4. And this axis you have also changed it by t square plus 4. So now if you again see the plot of this t square plus 4 with respect to t square plus 4, then what we are going to do again, you are going to take the values of t square plus 4 and you will be checking value of x of t square plus 4, that is nothing but t square plus 4 only. Again, this value and this value is same, therefore what will be the values in t of t square by plus 4, that will only be the value of x of t square plus 4 also, and therefore for this the values will be same, plus 1, plus 1, plus 2, plus 2. So you can see that again if you plot t square plus 4 with respect to t square plus 4, then the graph is again going to be straight line that will be having value 1 at t is equals to t square plus 4 equals to 1. So by these two cases, what we have seen, that if we replace on both the axes t by any other variable, then the shape of the graph is not going to be changed. But now what you have to do is, for given signal x of t, you have to plot x3 of t, x4 of t or x5 of t with respect to t only. If you take the plot of x of t plus minus t naught with respect to t plus or minus t naught, then the shape of x of t and this x of t plus or minus t naught will be same. But now you want to plot x of t plus minus t naught with respect to t only, then the graph will be changed. So now we have to see the replacement, how we replaced variables. All the operation performing any operation is all about the making replacement. So how we replace? So if we see, we will be taking the example to clear this point later on, but if we are starting now, our third operation, that is time shifting operation. Third operation that we are going to take is time shifting operation. So for a given signal x of t, we are taking any signal x of t to define this operation, and for REs, we are taking a signal that is having values from -4 to +6 and the value is let 10. Let it is your signal x of t. So what we have discussed is, if it is the plot of x of t with respect to t, so if we have to plot with respect to t, so in time shifting operation, you will be given any signal x of t, and what you have to find is, we have to find for given signal x of t, we have to find x of t plus or minus t naught, where this t naught will necessarily be any constant value. It will be a constant, and these plus and minus signs, you know that if the sign is minus, then the shifting using negative sign, it implies delay, and if you are taking positive sign, then it implies advancement of the signal, advance. So what you are going to do in this time shifting operation, you are just going to slide your signal x of t on this time axis, either left hand side or right hand side. Nothing will be changed in the amplitude of the signal, as these operations only have the effect on time axis. So now if you have to plot x of t plus or minus t naught, so we must understand the time axis part. Time never goes back. It means time only moves forward. Therefore, if it is your time axis, let it is your time axis. Then if you are mentioning the time, let it is 1 p.m, let it is 2 p.m, 3 p.m, 4 p.m, 5 p.m and so on. It will be the time 5 p.m. and so on. So what does it mean by advancement, or what is mean by delay? If you have to delay any work, if you have to do any work at 3 p.m. and if you are going to delay that work, then you will be doing that work either at 4 p.m. or 5 p.m. or 6 p.m. That means if you are delaying any work, if you have to do any work at this 2 p.m. instant, if you are delaying that work, then you will be doing it at 3 p.m. or 4 p.m. or 5 p.m. Therefore, you can see that if you are delaying any function, for delay what you will have to do is you will have to shift that signal towards right hand side because you are delaying that function. And if you are advancing, if you have to do any work at 5 p.m. and if you want to do that work in advance, then what will you be doing? For the work at 5 p.m. if you are going to advance that work, then you will be doing that work either at 4 p.m. or 3 p.m. or 2 p.m. or 1 p.m. So in which direction you are moving now? You are moving in left hand direction. If you are advancing, for advancement you will have to move towards left hand side. So these are the operation. If you have to time shift any operation, then you must have to slide that signal either right hand side or left hand side. And if it is negative sign, then it means you have to delay that signal. Therefore, you will be delaying that signal, that is, you will be shifting that signal towards right hand side. If there is sign of plus, then you will be advancing that signal, therefore you will be shifting that signals toward left hand side. So to perform or you to find x of t plus or minus t naught, what you will have to do? Shift x of t towards, if we are taking positive sign, so then shift x of t towards left side for negative sign and towards it is for positive sign. If you are advancing the signal, that is if positive sign is given, then you will be shifting the signal towards left hand side to advance that signal and shift the signal right side for negative sign, if it is sign is negative, by t naught. Whatever is the constant given after t, this plus and minus sign, that will be the shift provided by you, and this sign decides that whether in which direction you are going to slide your signal. So there will be, if there will be positive sign, then you will be shifting the signal towards left hand side. If there will be negative sign in shifting, then you will be shifting your signal towards right hand side. By how much amount? By t naught, which will be necessarily a constant. Therefore, just you can obtain that signal. Now if you see what we have just discussed, that if we will be changing the t value on both the axes, then signal will not get changed. It means that if this signal x of t, and if we have to plot x of t minus or t minus 4, if you have to plot t minus 4, and if you write this axis also as t minus 4, what we have did? If x of t is a signal which is existing from minus 4 to 6 having amplitude 10, then if you are taking this, if you have replaced both of these t's by t minus 4, so this axis makes x of t minus 4 and this axis will be t minus 4. Then you will be seeing then there will not be any effect on the plot. That is, if the plot of x of t with respect to t is this, then the plot of x of t minus 4 with respect to t minus 4 will again going to be the same without any change in that function. That is, it will be again having value 10 from minus 4 to this value is 6. But now what we have to do is we have to plot x of t minus 4. If we have to plot x of t minus 4, we have to plot x of t minus 4 but with respect to t only. Now we don't want to plot x of t minus 4 with respect to t minus 4, but we want to plot this x of t minus 4 with respect to t only. So now if t minus 4 value is 6, if we will be plotting x of t minus 4, then shape of the signal would be like this. Now if you are saying that you have to plot with respect to t, so these value, that is either 6 or minus 4, these are the values of t minus 4. So if t minus 4 is equals to 6, then what will be the value of t? That is minus 4 will get this side and will get added, therefore this t will be 10. And if t minus 4 is equals to minus 4, then what will be the value of t? That is equals to minus 4 plus 4, that is 0. So what you have concluded, that if you have to plot x of t minus 4 with respect to t minus 4, then the graph would be the same. But if we have changed this t by t minus 4, maintaining this axis to be as t only, then the shape of the signal will be like this only. But now these instants with respect to t, if we are seeing, then now these instants will not be minus 4 and 6, but it will be 0 and 10. Therefore, now if you have to plot signal x of t minus 4, then this signal will be existing from t is equals to 0 to t is equals to 10 seconds without altering any change in this value, that is amplitude will be fixed at 10 only. So now if you verify the signal using this concept, what you have to do, if for this signal x of t, if you have to find out x of t minus 4, then due to this negative sign you just have to shift this signal towards the right hand side. By how many distance? Here it is, the t naught constant value is 4, therefore you are going to slide this signal by 4 units in time towards right hand side direction due to the negative sign. So if you are going to slide this signal towards right hand side by 4 units, then this 4 will come at 0 and this 6 point, after sliding by 4 units, this 6 will move to 10. Therefore you have plotted the signal x of t minus 4 with respect to the t that is existing from 0 to 10 seconds. So now if you see here, again for any example you can, we are taking for continuous time domain only, we will be seeing these operations for discrete time simultaneously also. But if we discuss some of the properties, that if you see the area of this signal x of t, let it is x of t, then area of this signal x of t, which is a rectangular function having width 10 and height 10, therefore area of this signal is going to be 10 into 10, that is equals to 100. Now if you see here, again the width, that is from 0 to 10 seconds, again this rectangle is having the width 10 and the height is again maintained at 10. Therefore if you see here, the area a dash is also, we are again having it is the value 100. Therefore we can say that there is no effect on area of any signal after applying time shifting operation. It is obvious because we are just sliding the signal either left hand side or right hand side. The value of the signal is maintained, the total width is maintained, therefore the area is going to be maintained. So what we can write for this time shifting operation, that after time shifting, what will be the change? Area will be maintained. Area will remain same. Now if area remains same, and you can say that absolute integrability or summability in case of discrete time signals, if you see, absolute integrability will also be maintained. That is, as the area do not changes, similarly you will see that the integration from minus infinity to infinity, magnitude of x of t dt will be same as that of magnitude of x of t minus 4 dt. Therefore absolute integrability condition will also be maintained, that is, if the signal was earlier absolutely integrable or absolutely summable, then after applying these operations, the signal is again to be maintained its property, that is absolute integrability is maintained. Now if you see the time width is again going to be maintained, because we have seen that we are just sliding the signal, either it is we are shifting towards left hand side or we are shifting towards right hand side. So the total width of the signal is maintained. Total width of the signal is 10 here also, and in this case we are also see that the total width is maintained at 10. Therefore you can say that time width is maintained. So what is the overall change? Existence duration. If you see, the signal was parallelly existing in between the limits minus 4 and 6, but now this signal is existing between 0 to 10 seconds. So you can see that the existence duration of existence, now it is going to be changed, maintaining area, absolute integrability and time width. So if you have to perform time shifting, then you must have to slide that signal, and the sliding direction will be decided by the either sign positive or negative. If the sign is positive, then you will be sliding the signal towards left hand side. If the sign is positive, then you are going to slide the signal towards left hand side for advancement, and if it is the sign negative, then to delay that signal you will be shifting that signal towards right hand side. Now if you see the similar operation on a discrete time signal, so you can perform this operation also, like if you are taking, in case of continuous only we are discussing now, if we have taken this signal, that is, it was your signal x of t with respect to t, which was earlier having a value in between minus 4 and 6 seconds, the value was 10. So how can you mathematically express this signal? You will write x of t is having a value 10 for the value of t in between minus 4 and 6, and now the signal is 0, you can say otherwise. It is the definition, mathematically you can define this x of t signal as this. Now what you have to find is, you are trying to find signal x of t minus 4. So now it comes the importance of replacement that we are going to discuss in almost every lecture. Therefore, it is very important, and if this is clear, then no need to explain any other property individually. Using this concept only, you can perform any of the time shifting or time scaling or time reversal operation using this concept only. So what you have did, here x of t is given and you are taking x of t minus 4. It means you have replaced t by t minus 4. So if you have replaced t by t minus 4 on left hand side, then you must have to replace all t on right hand side also. As this value is independent of t, therefore there will not be any change in this value. So this x of t minus 4 will again have value 10 only, but now you will have to replace this t by t minus 4. We have replaced t by t minus 4. So you must have to replace on right hand side also. Here the term is independent of t, therefore it is remained same, but if it will be 10t, then you must have to replace that t also by t minus 4. So now it is 10 for the value of not t, but now the value of t minus 4 in between 4 and minus 4 and 6. Now if you have to solve these kind of inequalities, so what you will be doing, if there will be function like this, let it is minus 4 must be less than t minus 4. So if it is positive sign in t, then do not shift that t. Note the point. If it is positive sign with t, then you don't have to shift this t on the other side. If there is negative sign with t, then only you have to shift this t on the other side. So as we can see here, t is positive, so keep t on this side only and move that constant to other side. So this minus 4 will go to other side, becoming plus 4. So the value will be this minus 4 and it will be plus 4. So what is the limit that you are getting now? Minus 4 plus 4, that is 0. So the sign is greater than, therefore this will be the limit for fit, that is t must be greater than 0. So using these two, you have obtained your first limit, that is the value of signal x of t minus 4 will be 10, for which duration first limit will be for t greater than 0. And to find the next limit, you will have to find limits from these two results. So if it is given t minus 4 less than 6, again you can see there is no negative sign in t, therefore you will not be shifting t to other side. You will shift t to other side only if there is a negative sign associated with t. Therefore you can write it here, t must be less than, this minus 4 will go to other side having the value plus 1, therefore plus 4, therefore the value will be 6 plus 4, and you are now getting your next limit, that is t must be less than 10. So combining these two limits, you can write now it is 0 otherwise. So now after solving these two limits, you can find that this signal x of t minus 4 is going to be 10 for these were the limits for t minus 4. But as you want to plot the signal with respect to t, that's why you need the limits of t, and therefore you have obtained that limit, t must be greater than 0 but t must be less than 10. Therefore the value of signal x of t minus 4 would be 10, but only if the t is greater than 0 and less than 10, and the signal will be 0 otherwise. If you are going to plot this signal, x of t minus 4, which will be having value 10 but only in the duration 0 to 10 seconds, then you are going to get nothing but this signal that we have just obtained. It is x of t minus 4 which is having value 10 only between t is equals to 0 to 10 seconds. So therefore it is the meaning of replacement of signal that you are going to use everywhere whenever you are performing any time related operation. What you have to do is first express that signal x of t mathematically and then replace on both the sides the t value whichever you want to replace. That is, if you want to find x of 4t, then replace, like if we are taking one more example on this time shifting, it's okay for the time being. Now we can discuss this time shifting operation on discrete time signal. So to discuss the time shifting operation on discrete time signal, it is not of any use now, so we can rub it. Now if we want to see the effect of this time shifting operation on a discrete time signal, time shifting on discrete time signals. So if we are taking for an example, let we are having a signal x of n that is equals to values 1, 2, 3, 4, 5 are contained, these values are contained in signal, and let the origin is at t is equals to n is equals to 4. The origin n is equals to 0, at origin the value of the signal, that is sample of the signal, is having value 4. So now again if we want to find for the given signal the time shifting operation means we just have to find for this given signal x of n, we will have to find again x of n plus or minus n naught. Exactly same definitions we are going to use here also. The same procedure will be followed whatever you have followed in case of continuous time signal. So if there is negative sign, then it means delay, and to delay any signal the shifting will be towards right. For negative sign it means you are going to delay any function, and to delay any function you are going to shift that function towards right hand side. Similarly, if there is sign of positive, that is you are going to advance any signal, this sign positive again it means advancement, and to advance any signal shifting will be towards left. Now there are two concepts. Either you follow these concepts, that is you have to shift this entire signal towards left hand side for advancement and towards right hand side for delay, or you can see that if you suppose you are going to shift this signal one time towards right hand side. So if you shift this signal one time towards right hand side, then what will going to happen is this origin will be at this 3 value. So it means that if you are going to shift this signal towards right hand side, then it implies that origin is going to be shifted towards left hand side. If the signal is going to shift towards right, then origin will be shifting towards left, and vice versa. If you are going to shift your signal towards left, then origin will be shifting towards right. So to perform time scaling operation in much effective way and to avoid any kind of mistakes, you can go with the origin value. If you have to shift this signal 3 times towards right hand side, then you just take this arrow mark and shift this signal 1, 2, 3 times towards left hand side, and you will be having your signal x of n plus 3. Let for this given signal x of n, if we have to find out x of n plus 2, if we have to find signal x of n plus 2 for this given signal, then after time shifting all the values will be maintained in the signal, that is all these 5 values will again in the signal x of n plus 2 also. So the signal value you can write first 1, 2, 3, 4, 5, and now to decide where is the origin now, it means for plus sign what you have to do is you have to shift this signal towards left hand side. Therefore this origin will be shifting towards right hand side. If you shift this origin one time towards right hand side, so it will be at 5. Now if after 5 or before this one nothing is given, it means that all the sample values before this one is 0, and after this 5 all the sample values are again 0. So if you have to plot x of n plus 2 for which you have to shift this signal 2 times left hand side, or you say that you have to shift this origin 2 times right hand side. So if you shift the origin one time, then it will be at 5. You have to shift the origin 2 times, and here you are not seeing any value, it means the value after 5 is 0. So you will be plotting this signal to be like this. Now it will be your signal x of n plus 2. What you have did is you have shifted signal towards left hand side, therefore origin came towards right hand side by 2 units. Earlier it was having the value 4 at origin, the signal x of n, but now the signal x of n plus 2 will have origin. You have shifted that origin 2 times, as there were no samples given after 5, so you have taken zeros. If you have to shift, let for the same signal, if you have to find x of n plus 5, if you have to find signal x of n plus 5, then what will be the signal? You are going to shift this signal 5 times towards left hand side. It means this origin will come 5 times towards right hand side. So if there are no points given after 5, so it can be taken as, if no point is given, so you can take 0, 0, 0, 0, as many zeros as you can take. So now if you have to shift this origin, how many times? 5 times towards right. So 1 time, 2 time, 3 time, 4 time, 5 time. It means now the values will again be 1, 2, 3, 4, 5 3, 4, 5, but after 5, 1, 2, 3, 4, 5. You will have to take origin here. It means now you will have to append 1, 2, 3 and 4 zeros after this 5. So it will be 1, 2, 3 and 4, and now here it will be your origin. So you just have shifted your signal towards left hand side, and to shift your signal towards left hand side, you have used the concept of shifting the origin, and you have shifted the origin towards right hand side. As there were no samples after 5, so you have taken zeros to represent that signal, and then now you can say that the origin is having at this point. And now if you see, so what is the value of this signal n at this point? It is n equals to 0, so this is n is equals to 1, n is equal minus 1, it is for n equals to minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, and this value is for n is equals to minus 8. Here the value of n is minus 8, and here the origin, it is origin, therefore the value of n is 0 here. So we can see the concept of this also again in case of discrete time signal, but we will not having space, so we will be seeing it later.